Howdy again, Mustangs. Got another video coming at you here. This one is going to be related to how to solve quadratics by using the square root method or by completing the square. We have a lot of different methods when it comes to solving quadratics, and by definition, remember, quadratic is anytime we have a square somewhere in my problem, and that's the highest degree that we have. There's factoring, there's guess and check, there's grouping, there's a square root method, completing the square, quadratic formula, using the calculator. These are just two of the methods right here. And what I'm going to do in this video is I'm going to show you how to do the square root method and then how to do the completing the square method. And then also I'm going to show you how to check your answers on the Desmos calculator, okay? So let's get started. We use the square root method whenever we have the absence of an x term. So if we just have like a quantity being squared, or we have a variable being squared and there's no other x involved, we can use that. Like if you look at number 2, this is not a problem I would probably use the completing the square method for. I'm sorry, the square root method. We could, it doesn't matter, but it's through trial and error you kind of learn what's the best method. So let's look at the first one here though. What we're trying to do with the square root method is we're trying to isolate the part that is being squared first. So for isolating this, that means we want to try to get that square that's right there alone. So that means we have to take the 2 that's there, move that over, and then we have to divide it by 10. So if we take the 2 and move that over, we're going to end up with 11. Okay, no, what am I saying? 20. And then we divide by 10, we end up with a 2. If I take the square root of this is why we use the square root method. If we take the square root of this, what's going to happen is the square and the square roots are going to cancel each other out because they're inverse operations, and we're left with an x. And then we're left with the square root of 2. Now it's important to know that whenever we take the square root when we're solving, remember that generates 2 answers for us. The degree in this, which is the degree of 2, tells us that there's going to be 2 answers. To take care of that, as soon as we take the square root, we go ahead and attach a plus or a minus, and that tells us what our 2 answers are. So let me jump over to Desmos here so you could see this. Oops, not that. With the Desmos here, if you look at the first problem here, this is what the graph is going to look like if I just throw it in the calculator. And when it says that the answer we said was square root of 2, you can see that I put underneath it that the answer was square root of 2, it's 1.414. If you look at the actual graph and touch at the x-axis, the x-intercepts, touch it twice, what will happen is it'll populate that coordinate. So you see the first one is at negative 1.414, which is the negative square root of 2. And then the other one is to the right, which is positive 1.414, that there's 2 answers on the x-axis there. Okay? Let's turn that off, go back. Okay, so our next question. Whenever we say a quantity, what we're talking about is something that's been grouped together. So in this one, we've got the quantity 3x minus 4, and that's what's being squared. And you'll notice that there's no other, outside of here, there's no other x's anywhere in the problem except for inside that quantity. So this is one where we can use the square root method. So what we're going to do, just like before, we're going to isolate the quantity. We're going to isolate what is being squared. And from there, we'll take the square root and we'll continue on. So in order to isolate this quantity, we have to take that 7 that we see there. We're going to move that over. And then we're going to take the 2 and divide everything by 2. So we are going to have 2, 3x minus 4 squared is going to equal 20. That's by adding 7. Divide by 2, we end up with 3x minus 4 squared is going to equal 10. And now we're ready to get rid of that squared portion there, and we'll go ahead and take the square root of both parts. So if we take the square root of this, the square and the square roots will cancel, leaving me with 3x minus 4. And then we said before, as soon as we take the square root, we have to throw in our 2 answers. So what that means is we're going to have a plus or a minus a square root of 10. Okay? In order to finish solving this now, we have to still get x by itself. So let's take that 4 and move it over, and then take the 3 and move it over. So in order to move over that minus 4, we're going to add 4. We end up with 3x is equal to 4 plus or minus the square root of 10. And then we divide everything by 3, and we end up with x is equal to 4 plus or minus the square root of 10 over 3. So those are our 2 answers for this problem. It's not pretty. It is what it is. It's actually faster than if you were to do the quadratic formula or try to actually square it out first and then go from there. But this is our answer overall. Let's check to make sure that our answers do agree with the graphs. Let's go back to Desmos here. I'm going to turn on that second equation there, and there in green is what the graph should look like. If I touch each one of these points here, you can see that there's 2 times where it hits the x-axis. That's why they're called x-intercepts. And those answers are at 0.279 and 2.387. And you can see from the answers that are written there, 4 minus root 10 over 3 and 4 plus root 10 over 3, those are the 2 answers. Okay? All right, let's go over now. So that's completing, that's the square root method. Let's go to completing the square. The whole reason that we use the completing the square method is actually so we can use the square root method. And the way this works, it's a very simple process. It's just that it can get a little dicey. There's some mistakes that happen along the way here. But let's go ahead and work through this. So when we're completing the square, we're trying to get this to be a binomial squared. I'll show you what that looks like in a moment. In order to do that, though, the first thing we have to do is get this x squared to be a 1. We have to get rid of the number that's there. We want to make it a 1. This one is already equal to 1, so we're good. The next thing we want to do is try to go ahead and get that boxed portion, the x squared and the x, all by itself. So that means that that 48 has to get moved over to the right side. So that means that we're going to have x squared, we're going to have x squared plus 2x is going to equal 42. That's just by adding 48 to both sides. Okay. Now, completing the square. Completing the square is taking into account the fact that if I gave you a binomial, let's say I gave you like x plus 3 squared, and I was to multiply this out, x plus 3 squared is the same as x plus 3 times x plus 3, which is x squared plus 3x plus another 3x, and then plus 9 when you go through and multiply that out. So that's equal to 6x plus 9. Now, whenever we have a binomial and we square it, there's this pattern that happens. The pattern that forms is that this 9 that's right here is just that 3 squared. Okay? And the pattern that forms with the middle term is that this 3 right here and that 6 is always going to be double that term right there. And that's because of the fact that that 3 gets counted twice. So to complete the square and make this into what we call a perfect square trinomial, which is what this example here is on the right side. This is a perfect square trinomial. What you have to do is find a number that's going to go in this spot here, and whatever we add to it, we're going to balance it by doing the same thing to both sides. How do we do that? Well, what we're going to do is we're going to look at this term right here. In order to find this, we're going to cut it in half. So if I take half of 2 is equal to 1. Okay, and then I square the 1. That means what we're going to do is 1 squared is just 1. That means we're going to add a 1 here, and we're going to add a 1 over here. Okay, so let's finish this now. We just turned this into a perfect square trinomial because now I can factor this and make this x plus 1 squared, which is going to equal 43. Okay, because x plus 1 times x plus 1 is the same as x plus 1 squared. I'm sorry, and that x plus 1 squared is the same as x plus 1 times x plus 1. We just said that. That means that we have x squared plus 1x plus 1x plus 1, which now means we have x squared plus 2x plus 1. So we just turned this into a perfect square trinomial. Okay? So it's real simple. Just cut it in half, square it. Now that we have that quantity alone, we can go ahead and take the square root to get rid of the square. And we're left with x plus 1 equals plus or minus the square root of 43. One more step to get x by itself. We'll subtract 1. We end up with negative 1 plus or minus the square root of 43. So this is an exact answer with the square root, but let's take a look at what it is when we have it as a decimal. Okay, so let's go back over to decimals here. Okay, let's go ahead and put in that first problem that we just had there. Okay, that x squared plus 2x minus 48. Let's look at the graph of this. I'm going to have to zoom out in order to see it. And you can see that there's 2 blue lines there, one on the left, one on the right. Crosses the x-axis twice. There's the first answer, there's the second. And you can see that those 2 numbers match the answers that we have from negative 1 plus root 43 and negative 1 minus root 43. Okay? All right, let's jump over to one more example here, and that's 3x squared plus 20x plus 36 equals 4. This one's going to be a little bit of a doozy. And the reason this is a terrible problem to use the completing the square for is because of that 3 right there. I can't have that there. And I want to use some other method usually when we have this, whether it's guess and check, quadratic formula, something. But it's okay to still do completing the square here. But it's going to be a harder problem. So let's work through this. First, let's go ahead and isolate this. Okay. And that means we're going to have 3x squared plus 20x is going to equal negative 32. Okay, that's my subtracting 36. I need that 3 to go away. So divide everything in the problem by 3 to make this balanced. So divide this by 3. We're going to have x squared plus 20 over 3x equals negative 32 over 3. Okay, we're ready now to complete the square. Now this is not going to be a pretty number. Keep it as a fraction. It's always easier to keep it as a fraction in my opinion. But if I keep this as a fraction, here's what's going to happen. That 20 over 3, let's cut that in half. So that's the same as multiplying by 1 over 2, cutting it in half. And what we get is 10 over 3. Okay, the 20 and the 10 will simplify. The 20 and the 2 will simplify. We end up with 10 over 3. If I square that now, 10 over 3 squared is going to give me 100 over 9. Okay, so I'm going to add 100 over 9 here, and I'm going to add 100 over 9 here. Okay, now bear in mind, I'm doing this all without a calculator. So feel free to use a calculator. This will speed things up a little bit for you, but let's carry on. Now that we have a perfect square trinomial on the left side there, let's go ahead and put in the value that's going to go inside of my squared quantity there. And it's always going to be half of that middle term, or the square root of the last term. So half of it, which is right here, is 10/3. So we're going to add 10/3. Okay. On the right side, 100 minus 32 over, or 100 over 9 minus 32 over 3. What I'm going to do is I'm going to get these denominators to be the same. So if this is going to be the same, I have to multiply this by 3, which makes this negative 96 over 9 and 100 over 9. That means that if I do 100 minus 96, that's going to equal 4 divided by 9. Okay, let's carry on. Now that we have the squared part alone, let's go ahead and clear out that square by taking the square root. And we end up with x plus 10 over 3 is going to equal plus or minus 2 over 3. Move the 10 over 3 over. We get x equals negative 10 over 3 plus or minus 2 over 3. That means we have negative 10 minus 2 over 3, which will equal negative 4. And then negative 10 plus 2 over 3, which will equal negative 8 over 3. And these will be our two answers. Let's check it on Desmos here. So this is what our graph looks like. Okay, you can see there's that dark black right there. I'm going to zoom in on those. Touch the spots where they hit the x-axis, and we will see negative 8 over 3 is negative 2.667, and then the other one is negative 4. Okay. I know everybody wants to know, like, well, when do I use this, when do I use that? You use it when it says the directions tell you to, but generally with practice, you figure out what's the best way to actually tackle these, okay? Don't forget to like and subscribe. You take care. Have a wonderful day.